Hello, you guys. Good morning. Today we are going to tackle lesson 5.1. So we're kind of going backwards. We're backtracking to lesson 1. Um, so if you were in morning meeting, we've kind of already talked a little bit about factors together. If you're just joining us, that's okay too. We are on page 280 in your math journal. So go ahead and grab that. You also need your pencil and maybe a multiplication chart if you need it. Um, yeah, so we are going to be talking about finding factors today. So remember that factors are just numbers multiplied by another number to make a product, or to make a product is the answer to a multiplication problem. So like for example, I know that two factors of 10 are 1 and 10 because 1 times 10 is 10. Or factors of 10 could be 2 and 5 because I know 2 times 5 is 10. So factors are just the numbers that you are multiplying. And so there are a couple different ways to think about factors or finding factors. If you have your math facts memorized, this is going to be a piece of cake for you. Because it's really just going to be recalling your memorized facts. Your book, though, on page 280 shows you a couple different ways to do this. So number 1 says use the array to name the factors of 12. You probably talked about arrays in 3rd grade, maybe even in 2nd grade when you very first started talking about multiplication. An array is just a visual model to show you factors. So like on this first one, it's showing you one row. A row goes across one row, and if you count up how many in the row, there's 12. So that this array or model shows that 1 times 12 is 12. Because if you literally count up the number of boxes shown, there's 12. On the second one, the rows, if you count the rows, there are 4 rows going down, and in each row there are 3 blocks. And so you probably learned about area models when we said that if you counted each box in this second model, you'd get 12. But a faster way to do that, instead of counting them, would be multiplying the 4 rows by the number in each row. So 4 times 3 is 12. And then the last one is showing 2 rows of 6. If you count, there are 6 going across. And so that array shows 2 times 6 is 12. So looking at these arrays, it is telling you all the factors of 12. It says the factors of 12 are 1 and 12, because 1 times 12 gave me 12. 3 and 4, because 3 times 4 is 12, and then 6 and 2. I was probably supposed to write those in order from least to greatest, but I guess it doesn't matter too much. But those are the factors of 12, and so that's one way to think about factors. So like when you look down to number 2, it says, use tiles to find all the factors of the product, record the arrays, and write the factors shown. So you could try to make little rectangles like the ones on number 1 to equal 5. So try to think of what a rectangle would look like if there were only 5 boxes in it. So one example could be you could do one row of 5 and it would look like this. 1, 2, 3, 4, 5. And so one row of 5 would equal 5. That's one array, or one rectangle that equals 5. So just thinking about that, now I know that 1 times 5 is 5. And the factors of 5 are 1 and 5. And then you'd try to think of another array you could make using different numbers. However, I will tell you the only factors of 5 are 1 and 5. If you don't like making models, for example, I'm just going to tell you there might be an easier way. I call it a factor rainbow because it kind of looks like a rainbow, and also you guys know I love rainbows. So off to the side, I'm going to show you what it looks like. So if I'm talking about the number 5, I'm going to put that in the middle. This is going to be easy if you know your facts now. So think about all the facts that will equal 5. I can only think of 1 times 5, so I'm going to put 1 and 5 and draw a little line that kind of looks like a rainbow. So that's one pair of factors because 1 times 5 is 5. And so this one was easy because there's only the 2 factors. So the factors for this one are just 1 and 5. But like look at number 3 for 20. So you could think of different ways to make 20 on your grid here. One way could be 1 row of 20. I think that's 20. If you counted that up, 1 row of 20, there should be 20 boxes in my array. So you could think about other ways to make 20 using different rectangles. You could do 2 rows of 10, for example. 2, 3. I think that's 10. So 2 times 10 I know is 20. And then you could think of more ways to make 20 with different rectangles, different arrays. Again, might not always be the easiest way to do it. So if you make a little rainbow off to the side, put 20 in the middle, and now start thinking about factors of 20. I will tell you that all numbers have a factor of 1 because 1 times itself is just that number. So my first factor always will be 1 and, in this case, 20, because 1 times 20 is 20. What else do we know? We know that 2 times 10 is 20. That's another layer of the rainbow. See, this one looks more like a rainbow. So then you could think about what else makes 20? I know that 4 and 5 make 20. And there's another layer. So I could add that to my grid as well. 4 by 5. You can kind of decide how you want to think about factors. Either way is fine. I will tell you those are the only factors of 20. However, if you were not 100% sure about this, I'm going to put these in order from least to greatest. I think on your questions tomorrow on Clever, it's going to ask you to put them in order from least to greatest. So I'm just going to do that now. You could use your divisibility rules from yesterday if you were not sure, for example, if 20 could be divided by 3. So think about going back to page, I believe it was 286, and looking at that green chart again. And if you weren't sure, for example, again, if 20 could be divided by 3, you could do the divisibility rules for that. So go ahead and try number 4, pause the video, see if you can list all the factors for 25, and then check back in when you're done. I'm going to just start with the rainbow. You can do the array if you want, but always, they definitely have a factor pair of 1 and 25. And then the only other one I can think of is that 5 times 5 is 25. So if I put them in order from least to greatest, 1, 5, 25. I'm only going to list 5 one time. You don't need to do 5 twice, even though the factors would be 5 and 5. Okay, we are going to jump over to the next page. If you think you got it, go ahead and try 5, 6, 7, and 8. You may need scratch paper to show your work on. There's not a ton of room. But we are moving on to page 281. So go ahead and try the ones at the top, list your factors. If you can see on my video, I went ahead and moved the divisibility rules over to this page just to help us out. And so you can double check if you're missing any numbers or you're not sure if something can be divided by something else. So I'm going to show my work everywhere, basically. Here's number 5. I know that 1 and 9 are factors of 9. I also know that 3 times 3 is equal to 9. I also don't think there are anything else. There are any other factors. So my factors for 5 are 1, 3, and 9. All right, try number 6. 1 and 21. Alright, so let's say, for example, you didn't know if 21 could be divided by 2. If you flip back to your divisibility rules, remember we marked the page whenever that was on Wednesday? Tuesday. Earlier this week, we marked the page. Go back to the rules, and for example, if you didn't know if 21 could be divided by 2, it says the number must be even. 21 is not even, so I know that it can't be divided by 2. However, one of my basic facts is 3 times 7. So I know that 3 is a factor. However, if I didn't know, you could use the rule. It says the sum of the digits is divisible by 3. So if you were to add 2 plus 1, the 2 digits, you get 3. Since 3 can be divided by 3, then 3 must be a factor. So my factors for number 6 are 1, 3, 7, and 21. All right, go ahead and try 7 and 8. 17, 1, and 50. Okay, so then now I can't think of any other factors, but just to double check, look at my divisibility rules. Check 2, the number is even. 17 is not even, so it can't be divided by 2. Try 3. The sum of the digits is divisible by 3. If you add 1 and 7, that cannot be divided by 3. Try 5. The last digit is 0 or 5. That's not true because it's a 7, so 5 will not work. Number 6, the number is even and divisible by 3. Those are both not true. And lastly, for 9, the sum of the digits is divisible by 9. 1 plus 7 is 8, so 8 can't be divided by 9. So the only factors for 17 are 1 and 17. All right, I'm going to have to erase my work to do number 8. All right, I'm going to do it down here. 1 second. Okay, so for number 8, we have 18. If you know your math facts, go ahead and do this on your own. See if you can get them all. I know 1 and 18 for sure. Since it's an even number, I know it can be divided by 2. It's 2 times 9. Since the digits 1 and 8, 1 plus 8 is 9. 9 can be divided by 3. I know that 3 has to be a factor. It's 3 and 6. I don't think anything times 4 will give me 18. The last digit is a 0 or a 5. Is not true, so it can't be divided by 5. And then 6, we already listed as a factor. And so I think we got them all. because then for 9, we also already listed that as a factor. So my factors for 18 are 1, 2, 3, 6, 9, 18. That's a 9. All right, we are going to try just a couple more. If you are doing well on this on your own, go ahead and try 9, and then you could even do 10. Those are the last two that we're going to try. If you get stuck on 9, no big deal. We'll do it together. Number 9 says, Pablo is using 36 tiles to make a patio. Can he arrange the tiles in another way and show the same factors? Draw a quick picture and explain. So right now, looking at the picture, if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, he has 9 rows going down, and there are 4 tiles in each row. Can he still arrange the tiles but show the same factors of 9 and 4? Think about that for a minute. You could try to draw a picture. I believe he can. I think you can just flip it around. Instead of doing 9 rows of 4, I think he could do 4 rows of 9. And if you count, if you counted every little box up, you should also get 36 tiles. So down here, when we explain, we would say yes. You could say instead of 9 rows of 4, that's a comma, he could use 4 rows of 9, which is still 36 tiles. Remember, it doesn't matter what order you multiply in. 9 times 4 is 36, but 4 times 9 is also 36. That's why you can flip them around. Okay, then it says for number 10, how many different rectangular arrays can Pablo make with all 36 tiles so none of the arrays show the same factors? So really it's asking you to find how many factors, how many factored pairs we can do. So real quick, try to find all the factors of 36. 1 and 36, definitely. I'd have 1 row of 36. It'd be a really skinny patio. Then look at your divisibility rules again. Since 36 is an even number, I know it can be divided by 2. If you don't know what 36 divided by 2 though is, you need to go off to the side and do some long division. 2 goes into 3 one time. Get 1 left over. Bring the 6 down and you get, whoops, 18. So the next factor pair is 2 and 18. Okay. What about 3? The sum of the digits is divisible by 3. So if you were to add 3 plus 6 is 9. Can that be divided by 3? Yes. So I know 3 is a factor. And you might just know that 3 times 12 is 36. So use your rules, see if you can find any more factors. I know that 4 times 9 is 36. I think the hardest part of finding factors is making sure you get them all, which is why your rules, your divisibility rules would help. I don't think 36 can be divided by 5, but I do know for the 6th rule, the number is even, and we already said that it can be divided by 3. So that means that 6 must be a factor. Uh, 36 can't be divided by 7 or 8 and then we already have 9 listed, so 9's good. So I think those are all the factors. So what this is kind of saying is, how many different rectangular arrays can Pablo make with all 36 tiles so none of the arrays show the same factors? So like, you could think of it as 1 row of 36. You can have 2 rows of 18, 3 rows of 12, 4 rows of 9, 6 rows of 6. How many different rectangles was that? It was 1, 2, 3, 4, 5. So this is kind of asking you how many pairs. It's not asking you for how many factors. You could say 5 arrays, because there were 5 different options. All right, that is basically it for lesson 5.1, finding factors. Again, the hardest part is just getting all the factors in there. So let me know if you guys need help with anything or you have any questions, and I will talk to you later.